Welcome to a course on calculus. In this lecture, we are going to evaluate limits. Right? Without any delay, let us get into the lecture. First, the problem that we are going to consider is that f of x is absolute of x minus 4 upon x minus 4 for the case when x not equals 4 and 0 when x equals 4. Right? Now, we are going to check whether this function admits a limit at x is 4 or not. We have to check limit x approaches 4 f of x. This is what we are going to check. Here, when your x is 4, your function value is, that is f of 4 is 0. We will have to check whether the same matches with the left and right limits or not. So this is the given question. So let us do 4 minus, that is left limit we are going to evaluate. So when your x is less than 4, what is going to happen? Before that, let us examine the behavior of this function. Okay, this may also be written as when your x minus 4 is a positive quantity. Okay, the absolute gives you simply absolute of x means what? It is x if x is positive, minus x if x is negative, and 0 may be included in either case. You may include in both the cases as well. Right? No harm at all. Okay. Using this idea, we have to express this function. It is simply x minus 4 upon x minus 4 if x minus 4 is positive. Okay. Minus times of x minus 4 upon x minus 4 if x minus 4 is negative, and is 0 if x equals 4, that is x minus 4 is 0. Those are the three cases. We are going to get these cases out of it. So it is going to be minus 1 and it is going to be 1. So we know the behavior of the function. And here you may also see that this x minus 4 is bigger than 0. That implies what? X is bigger than 4, and this implies x is smaller than 4. Right? Now we are taking some value which is less than 4, which means what? It will land in this category. Therefore, this value is going to be minus 1. And similarly, limit x approaches 4 plus, that is the right hand limit that we are talking of the function at 4 is going to land in this category, and this value is going to be 1. Right? Here, the left limit as well as the right limit exist, but they are not equal. Hence, what can we say? Hence, we may say that limit x approaches 4 f of x does not exist. Okay. Now let us move to the next problem. That is, we have to prove that limit x approaches 0, x times of sine 1 upon x is 0. Okay. Blindly looking at it, we see that it trivially holds. But we have to prove it with the definition. What is the definition? That is, let me use the space. For every epsilon positive, there exists a delta positive such that here we are talking all these in real line. Therefore, 0 less than absolute of x minus c less than delta implies absolute of f of x minus l less than epsilon. Okay, you have to fix epsilon and then you will have to choose delta based on this epsilon. Okay, this epsilon as well as this point c, that is what we have to do. Okay, now okay, it is given that prove that this is happening. Okay, your L value is 0 as well as your C value is 0. Okay, this we will write it as limit x approaches C f of x equals L. So comparing this with this, you may note that what? These things are happening. Okay, now what is the thing you have to do? You have to identify epsilon first. Then based on that epsilon and the C value, that is 0, you will have to identify some delta such that these things are happening. Okay, first of all, let us calculate what this is. Okay, f of x minus L. Here L value is also 0. Okay, and this is simply what? This is absolute of x times of sine 1 upon x, and this may also be written as absolute of x into absolute of sine 1 upon x. Can we go further? Yes, of course. We know that what absolute of sine x is bounded by 1. This we know for sure. Be it any value here, you are going to get this quantity to be smaller than or equals 1. Therefore, you are going to get absolute of x. Right? Now, for any epsilon positive, okay, you can choose any epsilon. Based on that epsilon, you have to identify some delta. Choose delta to be epsilon itself. Here, why are we choosing so? Okay, here you see, this has to imply delta condition must imply the epsilon condition, such that your absolute of x is less than delta. This is what you are choosing. So if you are choosing this way, then this implies what? Absolute of x times of sine 1 upon x minus 0 will be smaller than or equals absolute of x, which is smaller than delta, which is same as that of epsilon. So comparing only these two things, what is this thing that you have? Absolute of x times of sine 1 upon x minus 0 is less than epsilon. That is what you have, right? So by the definition of a limit, we have proved this. So, and this completes the proof. Okay. And similarly, the next problem that we are going to see is that we have to show that limit x approaches 3, 1 upon x minus 3 to the power 4 is infinity. This is what we have to do. Okay. Suppose here it is going till infinity. Okay. How are we going to achieve it? The same thing, when we have to say this is going till infinity, we have to say something extra here. This must imply this is bigger than or equals epsilon. That is what we have to do, right? Only that change we have to establish. Okay, but x approaches 3, 1 upon x minus 3 to the power 4 is infinity. Okay, this is what we are given. Now, let us choose some g, a positive number, and this number may be, however, large. You may choose any larger value. Okay, you are choosing such that absolute of 1 upon x minus 3 to the power 4 is bigger than g. So you can always identify some quantity like this. Okay, this implies what? Simply 1 upon x minus 3 to the power 4 is bigger than g, because you are raising the power 4, which means it is going to be a positive quantity always. So this is what you have. Okay, and from this, what may you write? You may write x minus 3 to the power 4 is less than 1 upon g. Okay, and this is going to give you x minus 3 is smaller than 1 upon g to the power 1 upon 4. Now, so if you choose your g to be the epsilon value, this will serve you as the delta value. Okay, here what are you having is that here absolute of x minus 3 less than 1 upon g to the power 1 by 4 implies what? Implies absolute of 1 upon x minus 3 to the power 4 is bigger than g. This clearly tells you limit x approaches 3, 1 upon x minus 3 to the power 4 is infinity. Because whatever may be the value of the thing that you choose, you are able to identify some delta value such that this delta condition implies this thing. If you make this value to be a smaller and smaller one, this will turn to be a larger and larger one. So this is always bigger than this larger quantity, which means what? It is approaching to infinity. Okay. Now we will see another problem. That is, we have to evaluate the limit x approaches 0 plus, okay, 1 upon 1 plus e to the power minus 1 upon x. This limit we will have to evaluate. Okay, let us plainly look at it and see what happens. Just make your x is 0 here. What are you getting? You have 1 plus 1 upon 1 plus e to the power minus infinity, and e to the power minus infinity is 0, hence we are expecting to get 1. So we are expecting 1 as the limit of this. Hence we will start with this. So we have to try and identify something. Okay, this has to be less than epsilon for a suitable choice of delta. This is what we have to prove. Okay, for which what is it going to be? Okay, it is going to be absolute of 1 minus 1 minus e to the power minus 1 upon x upon 1 plus e to the power minus 1 upon x, and this is going to be simply minus e to the power minus 1 upon x upon 1 plus e to the power minus 1 upon x. And if you cancel these things in the numerator as well as in the denominator, and making absolute of minus 1 as simply 1, so you are going to get 1 upon e to the power 1 upon x plus 1. We are taking this quantity to be less than epsilon. This is what we have to establish. Okay, so when we take like this, and here you may see that what? So e to the power 1 upon x plus 1. This quantity is always a positive quantity, right? E power exponential is a positive function. So this quantity is going to be positive, and when we take the reciprocal, what are we going to get? We are expecting to get a bigger than 1 upon epsilon thing, right? So yeah, let us take that way, this way. Okay, fine. This is what we have, and this also gives us that what? E to the power 1 upon x is bigger than 1 upon epsilon minus 1, and this tells you your 1 upon x is bigger than log of 1 minus epsilon minus 1, and this gives you your x is smaller than log 1 minus epsilon minus 1, right? Now with this we are going to do our calculations. Here you see your x is approaching 0 plus, which means you will have to choose some delta such that these things are happening. Okay, now here just for the sake of convenience, I am choosing my epsilon value to be between 0 and 1, so that what? It stays a larger quantity which is bigger than 1. Okay, and when I subtract 1, it still remains a positive quantity, and such these things are happening. Okay, with this, for absolute of x minus 0 less than log of 1 upon epsilon minus 1, we have absolute of 1 plus 1 upon 1 plus e to the power minus 1 upon x minus 1 is less than epsilon. This is what we have. Hence, the limit exists in this case. Now, for epsilon bigger than or equals 1, let us see what happens. Just come to here. Okay. Be it any value which is bigger than or equals 1, you just substitute here. What is going to happen? This will be a negative quantity, and this is always a positive quantity. A negative quantity is smaller than a positive quantity always. Hence, this is trivial. Okay, and hence what? Limit x approaches 0 plus to this function 1 upon 1 plus e to the power minus 1 upon x is 1, and this completes this problem. Thank you for watching.